Hello everyone, my name is Lutfi, and in this video, let's talk about isotopes. Okay, so what are isotopes? And these are the main subjects for this video, and so let's get started. Okay, uh, so we know that all the atoms of an element have the same number of protons. Okay, but some of them have more numbers of neutrons. Okay, so therefore the mass number, which is the sum of the neutrons and protons that are inside an atom, is different. Okay, so their names are isotopes. That is Greek for same place. Okay, and that's because all of the isotopes of one atom, okay, for example carbon, are all packed up inside the periodic table in one place. Okay, so all of them are how do I say it, in one place and not just scattered all over the periodic table. Okay, which that's because of the chemical properties that they have. Okay, and these isotopes were discovered by Frederick Study. Okay, so as an example, the atom carbon. Okay, it has the atomic number of 6. Okay, but it has different mass numbers, which are 12, 13, and 14. Okay, and can you tell me the number of neutrons that are inside each one? Okay, so you can just pause it and calculate and then tell me the answer. Okay, so the answer is 6 for the carbon 12, 6 protons, 6 neutrons. Okay, and 7 for carbon 13, and 8 for carbon 14. Okay, and if you don't know how to find out the number of protons and neutrons or electrons, I have covered all of them in my previous video, and there's a link to it in the description below, so you can just go and watch that video, okay, to learn how to calculate those protons and neutrons. Okay, and so the most common carbon is carbon 12, okay, which accounts for 99% of the carbon in nature. Okay, and the other two carbons are only 1% in nature. Okay, and this man is Frederick Study. That was the one who discovered isotopes, and these are the carbons, all the carbons that are stable, and we will talk about this carbon 14 in a few seconds, because it's not completely stable. Okay, so now let's talk about how to find the atomic weight of each and every atom. Okay, so for this we have to find out an element. How many isotopes does an element have? Okay, for example, we know that carbon has 12 and 13 and 14, but because 14 is not that stable, okay, we will talk about that in a few seconds, we only need carbon 12 and carbon 13. Okay, and so we multiply the carbon 12 by the percentage. Okay, so 99% actually multiplied by 12. Okay, so as you can see in this picture, bottom picture, we are not writing 99%, we are writing 0.99, which is actually the same thing, but still. Okay, so we multiply that, and we multiply the other one, meaning carbon 13, by its percentage. Okay, so the percentage is 1%. We can and we just write 0.01. Okay, so and at the end we just when we find the answers, which for carbon 12 it is 11.88, and for carbon 13 it is 0.13, and we just sum up these two numbers, meaning 11.88 plus 0.13, and it equals 12.01. okay, as you can see in this picture. Okay, so 12.01 is the weight number of the atom carbon. And have in mind that all of the carbons, meaning C12 and C13, I mean carbon 12 and carbon 13, but all of them have 6 atoms. No, 6 protons, sorry. But if they didn't have the same number of protons, they would be other atoms. For example, they would be nitrogen or oxygen. Okay, so all of the protons are the same. And although the isotopes of an element have slightly different masses, they behave identically in chemical reactions. Okay, that's because they have the chemical properties. Okay, and they only differ in their physical properties, meaning weight and other stuff. Okay, and have in mind that both, as I said, both carbon 12 and carbon 13 are stable isotopes, meaning that their nuclei do not have the tendency to lose subatomic particles. Okay, which is a process called decay, which we are going to talk in few minutes. Okay, and radioactive isotopes is one which the nucleus decay spontaneously gives off particles of and energy. Okay, so whenever these isotopes are radioactive, okay, they decay. Okay, and actually they spontaneously give off particles and energy from their own atoms. And so the radioactive decay leads to a change in the number of protons. Okay, which the atom or the isotope actually transfers an proton. Okay, and actually transforms into a different element. So this is a very complex method. So yeah, we will cover them in other videos. Okay, so for example, when an atom of carbon 14 decays, it loses a proton. Okay, becoming an atom of nitrogen. Okay, radioactive isotopes have many useful applications in biology, which we will cover in our next video. Okay, and so that was all for this video, and until the next video, happy learnings to you all and stay safe.